So in this video, we're going to be using cosine to find the length of an unknown side. So just in case you're not familiar with what cosine is, we commonly refer to it as cos, and I will be using the two terms interchangeably throughout this video. So if you hear me saying cosine, I'm referring to cos, or if you hear me saying cos, it means I'm referring to cosine. So they're exactly the same thing. So if you're wondering what exactly cosine is, it is basically a trigonometric function that is equal to the ratio of the adjacent side in a right angle triangle to the hypotenuse. So that's really important. I'm going to highlight that. And I'd highly recommend, if you've got a highlighter, highlight that in your own notes. So remember that cosine is equal to the ratio of the adjacent side to the hypotenuse. Now, in case you've forgotten where the adjacent side is, remember that it is next to a given reference angle and the right angle. So let's take a look at the diagram that I have here to the right. So remember, theta is what's representing our reference angle. And notice here we have our right angle. And if you notice, you can see that the adjacent is right next to both. So I'm just going to highlight that as well. So when we're talking about cosine or the use of cos, we're talking about using the adjacent, the reference angle, and the hypotenuse. The opposite is not relevant when we're using cos. So if you take a look at the orange box to the left-hand side, I've written the key equation here, which says that cos of an angle, in this case theta, is equal to the adjacent divided by the hypotenuse. So hopefully you can sort of start to see how what the connection is, between the key equation and what I've mentioned as our first point, which is that the cosine function is equal to the ratio of the adjacent side to the hypotenuse. So let's have a go at doing the worked examples. Definitely have your scientific calculator on hand, because I am going to step us through the process of using our scientific calculator to help us find out the answers to both worked examples. So here we're asked to find the length of the unknown side for each of the following triangles. So let's start with the first one. So the first one here, like I always keep saying, label your triangles. It's going to make your life so much easier. So we know 17 is going to be our hypotenuse, and W is going to represent our adjacent side. So I'm just going to write A for adjacent. We know our reference angle here is 45 degrees. And the way, remember, we know that W is our adjacent is because the reference angle is there to our right and our right angle is there to the left. So that adjacent side is next to both. So if you're thinking about how we might represent this in an equation, what you're going to write is cos of an angle, and our angle this time is 45 degrees, is equal to the adjacent, which is represented by the letter W, divided by 17, which is our hypotenuse. Now again, here we're going to have to rewrite the equation so that we're actually able to use our calculator. So here I'm going to multiply both sides by 17. So they'll divide out. So I've got 17 times cos 45 degrees equals W. Now we can type in that into our calculator. So I'm just going to pull out my scientific calculator. Again, making sure that your calculator is in degrees mode and not radians. I'm going to type in 17 times cos. And then inside the bracket, you should be writing your reference angle. And it equals to, or W is equal to 12.02 units in length. So what we've just found is that the length of W is 12.02 units. Again, if I were to say that all the units for this particular triangle were in centimeters, meters, millimeters, whatever it is, make sure you give the units. In this case, I haven't, so I've just given you numbers. So my final answer will be W is equal to 12.02. Now, in our second example here, again, starting by labeling our sides or our key information, we know our hypotenuse this time is represented by the letter M. We've got an adjacent of 14, and we've got a reference angle, so I'm just going to write RA for reference angle, of 27 degrees. Now, putting this information into our equation, we're going to have cos of our angle, in this case 27 degrees, is equal to 14, which is our adjacent, over our hypotenuse, which is represented by the letter m. Now this time we are going to have to do a little bit more work, an extra step to the first question, so make sure that you do pay attention and you are very careful when you are doing this. So notice that our denominator for our ratio is actually a variable, or it's represented by a letter, so we need to rewrite this equation so that the whole thing is equal to m. So first I'm going to start by multiplying both sides by m. So then I've got m times cos 27 degrees equals to 14. So now dividing both sides by cos of 27 degrees, I'm going to get m is equal to 14 divided by cos of 27 degrees. Now again here, I'm going to type into my calculator. So just make sure you clear the previous working out. So I'm going to write 14. So I'm going to actually use the fraction button. So 14, move the arrow down, 14 cos 27 degrees. Again, make sure your calculator is in degrees mode, so look at where my arrow is. That should be D, not R. And that equals to, well, it's telling us that m is equal to 15.71. So my error here was not telling you to how many decimal places I'm after your answers to be. So let's just assume for the purpose of this task, it's 2 decimal places. So hopefully what you're able to see here is 2 different scenarios where we've used the general equation for cos in order to find the length of either the adjacent, which is the second example, or the hypotenuse. We used the first question to find the length of the adjacent, and we use the second example in order to find the length of the hypotenuse. Remember that from our work in Pythagoras, the hypotenuse is the longer side of the right angle triangle, so you want to make sure that the lengths that you do calculate when you are working out your hypotenuse is bigger than the other sides. Conversely, when you are working out the adjacent, you want to make sure that that length that you work out is smaller than the given hypotenuse. So hopefully now you feel a little bit more comfortable in terms of what cosine is, or cos, what it represents, and what is involved in using the cos function. Another way you can remember what cos actually involves is using ca. So that's telling us that we're after using the cos function, where we've got the adjacent on the top of the ratio, so that's our numerator. So here I'm just going to write h, which is obviously representing our hypotenuse, and in terms of the ratio, it does represent our denominator. So hopefully now you're feeling comfortable using cosine to find the length of an unknown side.